Hello everyone, let's continue our class. Before we go through another two different methods for investment project evaluation, let me ask you three trivial questions. First one, what is capital budgeting? Well, capital budgeting is a process of evaluating a company's potential investment projects to see if it's worthwhile or not. Capital budgeting is the most important decision for any corporation because it helps a company to generate the momentum of the growth, and it involves large expenditure. It lasts for many years, and the benefits of capital budgeting can benefit a company for the years to come. It's the most important decision for any corporation. Now, second question is, what does NPV indicate when you do capital budgeting? Well, NPV gives us very direct measure of how much the value that can be added to shareholders due to a certain project. If NPV is greater than 0, then we should accept the project, and if it's negative, we should decline the project. And NPV is the most popular methods for corporate executives to make investment decisions. And NPV considers time value of the money. It considers timing of those future cash flows, and it gives indication on the value that can be added to shareholders. So it's a pretty good method for professionals to utilize for capital budgeting decision. Now, the third question is, what are disadvantages of two other alternative methods? Payback time period method and average accounting return method. Well, those two methods are very easy method to utilize. Calculation is relatively easier than NPV. However, those two methods do have a lot of disadvantages and shortcomings. And both methods ignore time value of the money. Right? And also both methods require a preset benchmark to assist investment decision. And for payback time period method, it ignores cash flow beyond the cutoff time period, and in some scenario, it's not a reliable method to utilize. And the same problem exists for average accounting return method. Now, let's continue to see what other method that we can utilize to assist our capital budgeting method. And here is IRR. What does IRR mean? IRR means internal rate of return. Essentially speaking, IRR is the discount rate that makes NPV equal 0. And decision rule is pretty straightforward. We should accept the project if IRR is greater than the required rate of return of the project. Right? If IRR is less than required rate of return of the project, then we should decline the project. Now, let's take a look at mathematical aspects of IRR. Remember that in order to calculate NPV, we needed to calculate all present values of cash flows associated with the investment project, and all of the cash flow need to be discounted by using a required rate of return, or the discount rate are here. And if we set NPV equals 0, then this discount rate is equal to IRR, or internal rate of return. Calculating IRR could be very challenging assignment. Without a financial calculator, you might spend a couple hours or even a couple days to get results. However, your calculator, once again, one of your best friends, can help you to tackle this challenging assignment in less than a couple minutes or even less than 30 seconds, right? And here, when you use your financial calculator, you do the same steps as you do for NPV method, right? At the very last step, if you need to calculate NPV, you press NPV. But here you need to calculate IRRs. Then what you need to do is press IRR key on your calculator. Then compute. CPT means compute. Your calculator will show automatically the internal rate of return. And in this case, this project can return 16.13% annual rate of return. And this number is good because it's greater than required rate of return of 12%. And the decision here is pretty easy to make. We should accept this project simply because IRR is greater than required rate of return of this project. And here are some details of using calculator in calculating IRR. You do the same. Let your calculator know what those cash flows are, but here's a typo on the right hand side of the table. The C00 should be negative. It's negative $165,000. Once you complete all cash flow inputs, then you press IRR and CPT. Your calculator will show up 16.1322. That means 16.13%. If you know how to use Excel, then IRR can be easily calculated, and you simply initiate IRR function, right? And you simply include all the cash flows for a project and do IRR calculation. Just a one-step calculation. Here, this table showed you the process of using Excel spreadsheet to calculate IRR. You simply use IRR function, then you input the range of those cash flows from cell B3 to cell B6, and calculator will, your Excel spreadsheet will show you the answer in less than 5 seconds. Now let's take a look at so-called NPV profile for the project. NPV profile for the project. And here you see a red line. And this red line shows you NPV profile based on different discount rate. Higher discount rate means lower NPV because higher discount rate will generate lower present value. When discount rates are smaller, you see greater value for NPV. For example, at 2% of discount rate, the NPV is about $50,000. But when when discount rate increased to 12%, the NPV declined to a little over $10,000. When discount rate increased further to 16%, then NPV will decline to 0. And this 16% is IRR. Why? Because at this level, NPV declines to 0. So the IRR is the crossover point of two lines. The first one is this red line of NPV profile of an investment project, and the x-axis of this two-dimensional picture. Is IRR a good method to utilize? Well, we need to answer 4 questions. Does this method account for time value of money? The answer is yes. The second, does it account for risk of cash flows? The answer is yes. Does this provide indication about increasing value? Well, it doesn't provide absolute amount of dollar value increase for the company due to this project, but it does provide indication on rate of return, and it also permits project ranking because higher IR project, of course, is better than lower IR project. Should we use IR method as our primary decision criteria. Well, of course, IRR has many advantages, and it is intuitively appealing to corporation executives, and executives love to use percentages to compare returns of different investment projects. Right? It considers all cash flows. It considers time value of the money, and it provides indication of risk. So it's a pretty good method to utilize. That's why IRR is another popular method for professionals to assist their capital budgeting decision. Yet, IRR has several disadvantages. You need to pay attention to those disadvantages very carefully. First of all, IRR method sometimes can produce multiple answers, right? And for example, when you enter all the cash flow in your calculator will show you more than one answers, and the problem here is which answer to take, and how do you make a decision based on two different numbers. And the IRR cannot rank mutually exclusive projects. And also the IRR method has a fraud assumption associated with reinvestment. So let's examine a little bit further on the disadvantages of IRR. In most cases, both NPV method and IRR will generate exact same answer associated with capital budgeting decision. However, for some abnormal projects, for example, the project has non-conventional cash flows, which means cash flow sign changes more than once, and for mutually exclusive projects, NPV and IRR may generate conflicting conclusions. By saying non-conventional, we are referring to a project that generates negative cash flows in one-off time period. In the future, of course, initial cost should be negative, but for the future years, some project can generate negative cash flows. For example, the clearing expenses that a company need to take to shut down a nuclear power plant at the end of its life. Right? And sometimes a certain project can generate negative cash flow in certain years. If that is the case, then IRR may not be a good method to utilize, because your calculation can show more than one IRRs, and multiple IRRs cannot help you to make the right decision. And here's an example how you can generate more than one IRR for a non-conventional cash flow problems. Right? And here, the project will cost $90,000 initially and will generate $132,000 for first year and $100,000 for second year. But during the third year, it involves the cost associated with demolishing the project, which is the $150,000. And here, let's say required rate of return of 15%. Shall we accept or reject the project? Well, let's do IRR calculation. When you do IRR calculation, you will get two different numbers. One is 10%, the other one is 42%. If you use 10%, this is not a good project because less than required rate of return of 15%. But if you use second number, 42%, then it's much greater than its required rate of return. So shall we reject or accept the project? Well, the answer here is the IRR method here is not a good method to utilize, and we shouldn't make investment decision based on multiple IRRs. So if we have to make a decision, then what should we do? The answer is forget about IRR and go for NPV. NPV will give you a reliable results. And this picture shows you why this unconventional project can generate two IRRs. As you see, the profile of NPV cross x-axis for twice. And at the first crossover point you see 10%, and at the second crossover point you see 42% also. And for the project like that, IRR is not a good method to utilize. Now let's take a look at independent versus the mutually exclusive projects. By saying independent, the cash flows of one project are unaffected by acceptance of the other. In this case, let's say if companies are facing two potential investment projects, if both projects are good, then they can take both. If both projects are bad, they can decline both, or they can take one of them if one project is a good project. But for mutually exclusive project, company has to make a decision between those two projects. Maybe both projects are good, but the company can only take one of them. So this is called a mutually exclusive decision for investment projects. And the third problem with IRR is its assumption for reinvestment. And through the calculation, you see that we use IRR as the discount rate for future cash flows. And here we assume that an investment rate equal to IRR. In most cases, this is not a reliable assumption because a higher IRR may not be achieved for future reinvestment. Let's say you come across a good project and IRR is 25%. And since you use 25% in discounting those cash flows, therefore you assume that all the future benefits they are getting from the project can be reinvested at this 25% IRR. But the company needs new projects to make that 25% happen. Sometimes company may not be able to find that kind of good projects, and they might find a project that has a much lower IRRs. So conservatively speaking, IRR has a fraud assumption on reinvestment. And the less aggressive way to make a reinvestment assumption is to assume that reinvestment rate equals required rate of return. That's a much more realistic assumption for reinvestment. And NPV has a fraud assumption on reinvestment. That's why NPV may not be able to make a right decision when we are facing mutually exclusive projects. And if IRR is no good, then what should we do? The answer is pretty simple. Go for NPVs. And here's an example in evaluating two mutually exclusive projects, Project A and B. And Project A cost 500 and Project B cost 400, and those two projects generate positive cash flow for the next 2 years. And when we calculate NPV for Project A is $64, and for Project B is about $60. In this case, you would say, hey, Project A is better than B, therefore we should accept Project A. Although both projects are good projects, but we needed to make a mutually exclusive decision. We had to pick one of them, not both. So A should be picked for future investment. But when you look at IRR, the Project B has higher IRR, which is 22% versus 19.4% for Project A. And you would say, hey, based on IRR rule, we should choose Project B, but since this is a mutually exclusive project, IRR may not be a good method because its assumption for investment is not realistic. So it's better to stick with NPV to choose Project A in this case. Now, let's take a look at the crossover point problem for NPV profile. And this profile, this graph is based on the Project A and B that you see in the previous table. Right. And the red line shows you the NPV profile for Project B and Project A, and the blue line shows you the NPV profile for Project B. and those two lines has a crossover point, and that point is about the point stands about 11.8% of discount rate, and at the crossover point those two projects are equal to each other. But if the discount rate is less than the crossover point, you would say, hey, this red line is higher than blue line, which means project A is better than project B. But if the discount rate is higher than crossover point, then B beats A. Right? So when you make decision on capital budgeting, where you use both IRR and NPV method, you need to take a look at that crossover point. Right? If your required rate of return is less than crossover point, you will see both IRR and NPV will generate the same conclusion. But if cost of capital or discount rate is higher than crossover point, then we generate conflicting results. If that is the case, we go for NPV method. And here are two reasons why NPV provides cross and generates crossover point. The first one is size difference. The scale of projects can be different, and the second one is timing difference of future cash flows. And smaller projects frees up funds sooner for investments, and the higher opportunity cost, the more valuable those funds, so high discount rate favors small projects. As for timing difference, project with a faster payback provides more cash flow in early years for reinvestments. If discount rate is high, early cash flow especially is a better choice. When you come across a conflict between NPV and IRR, the solution here is very simple. You go for NPV. Because IRR could be unreliable in two different scenarios. The first one is non-conventional cash flows, and the second, mutually exclusive projects. Since IRR has certain disadvantages, but people still like percentage. They like rate of return, measure of investment projects. Since IRR has fraud assumption for reinvestment, so people dig deeper into this problem, and somehow they can find a solution to make IRR a better method to utilize. And here we simply develop a modified internal rate of return, or MIRR method, to control for the problem with IRR. So if you have problem with IRR, then the next step is to develop MIRR, and it's very likely that when you use MIRR, then you will see consistent results from both NPV methods and MIRR methods. MIRR method is a little bit complicated. It involves 3 steps. First one is, it involves 3 different procedures. First one is discounting approach. Second one, reinvestment approach. Last one is combination approach. But no matter which one you will use, you will notice that MIRR method corrected the reinvestment assumption in the calculation. And here, MIRR method assume that reinvestment rate is equal to cost of capital, or the required rate of return. Right? And here is the detailed steps for you to use 3 different approaches in MIRR. And it's not required for the class, but if you're interested in this problem, you should look at the 3 alternative methods. And MIRR can be easily calculated by using Excel formula. You simply initiate MIRR function, and you need to you need to enter the range of data for those cash flows. And the second, you need to enter finance rate as well as reinvestment rate. And in most cases, those two rates are the same, which means discount rate is set as reinvestment rate. And here's a visualized process in calculating MIRR. And here we have project that has negative cash flow at the second year, which is negative 100, and this project generates 155 positive cash flow in year one, and it costs $60 as initial investments. The required rate of return was set at 20%, and also we use this number as reinvestment rate. Right? And the first step that we needed to do is to get so-called terminal value of cash inflows. Terminal value of cash inflows. Since there's only one cash inflows, which is the 155, then we take the future value of the 155, which is equal to 155 times 1 plus 20%, which equals 186. Then we look at the present value of cash outflows. It has two outflows. The first one is initial investment, $60, and the second one is $100, negative $100 in the second year, and we need to discount the second year cash flow, and it equals negative 100 divided by 1.2 raised power 2, and that will give you discounted value of the 100 negative cash flow in the second year, which equal to $69.44. When you add up those two numbers, you get a negative $129.44 of present value of those outflows. Once you get those two numbers, you do the following calculation. You simply discount terminal value of cash inflows by using MIRR. Let it equal to the present value of outflows, and by solving this equation, you will get a modified IRR, or modified internal rate of return. And you can use, you can go through IMR method by using your calculator or using Excel. MIR is a modified IR, and I would say it's a IR method that overcomes its disadvantage associated with the investment rate. And MIR, in some cases, in most cases, can avoid multiple IR problem, and MIR can deal with mutually exclusive projects. And it's very likely that MIR will generate the same conclusion as NPVs. The last method that I'm going to introduce is profitability index. And the profitability index is very similar to NPV. It's just to take the different form. And the decision rule is very simple. If profitability index is greater than 1, then we should accept the project. If less than 1, we should decline the project. Right. And a profitability index of 1.1 implies that for every dollar of investment, we create 10 cents in added value for our shareholders. And here is the formula that we use to calculate the profitability index. It equals present values of all cash inflows divided by the absolute value of initial investments. Right. And the profitability index has advantages and disadvantages. First of all, it is closely related to NPV. And generally it will lead to identical decisions as NPV. And of course, this profitability index consider all cash flows. It consider time value of the money, and easy to understand and communicate. Is very useful in capital budgeting decision. However, it has a disadvantage because it may lead to incorrect decision in comparison of mutually exclusive investments. And here's an example. We have two mutually exclusive projects, A and B. Project A costs $10,000 and B costs $100,000. You notice that size is very different for those two projects. And present values of future cash flows is $15,000 for project A and $125,000 for project B. When we do profitability index calculation, we will see that A has higher PI than B, which is 1.5, higher than 1.25. So you would say intuitively we should choose A. However, if you calculate NPV, you will find the opposite because B generates greater value for NPV. So if MB, A, and B are independent projects, you may use PI, but since they are mutually exclusive, we have to stick with NPVs. In practice, financial managers, financial executives consider all investment methods that we introduced in this class. Yet, the most popular methods are NPV and IRR. For some scenarios, you may come across the conflict between NPV and IRR. The solution is pretty clear. We stick with NPV if we find that IRR has some problems. And the payback time period is commonly used as secondary investment criteria. It's not a primary method to utilize. And all 5 different methods provide valuable information for capital budgeting. So let's summarize what we learned so far. Right? And here we have 5 different methods: NPV, payback, AR, IRR, and PI. And most popular and most reliable method is NPV, and it shows the absolute amount of absolute dollar amount of value added due to an investment project. And the payback period is very simple method to utilize, but it has several disadvantages, and people use it as a secondary method for investment decision. And AIR is very similar to payback method. It's also a very interesting secondary method to utilize. And IRR is commonly used method for most financial professionals in corporations, and in most cases, managers use both NPV and IRR as primary methods. If IRR doesn't work out well, they will stick with NPV. And the PI, profitability index method, is very similar to NPV. It's very similar to NPV. Just that for mutually exclusive projects, managers should stick with NPV, not PI. Right. And here's a more summary for 5 different methods. Each methods have advantages and disadvantages, and I want you to pay attention to those disadvantages. And remember, the most important and most popular way for capital budgeting is NPV, and the second one is IR. And all the methods serve as secondary decision tools. Before we conclude this class, let's have a short quiz. Consider an investment that costs $100,000 and has cash flow of $25,000 each every year for 5 years. Let's say required rate of return is 9%, required payback is 4 years. So should we accept or decline these projects? Well, please use several different methods to assist your decision. First one is payback period. So what is payback period for this project? Second, what is NPV? Third, what is IRR. And the last one is, should we accept this project or not? Well, here this Excel spreadsheet showed you the calculation for this problem. And first of all, we list all of the cash flows in the second column. And on the third column, we calculate cumulated cash flows in order to get payback period. And the fourth column calculates discounted cash flows, and this column is used to generate NPV. And the calculation shows that the payback period is 4 years. Since the benchmark 4 year, it looks like this is a good project to take. However, NPV here is negative $2,758.72, indicating that this project will destroy value for shareholders. Therefore, we need to decline this project. And also, this spreadsheet can help you to calculate IRR, which is equal to 7.93%. Since this IRR is less than required rate of return 9%, therefore we should decline the project. Fortunately, we have consistent answers from both NPV and IRR methods, because this is a conventional cash flow problem, and also we are not doing mutually exclusive project decisions. All right, this is a pretty short chapter, but it involves a lot of mathematical calculations. I highly recommend to utilize homework to practice those calculations associated with NPV, IRR, profit index, payback period, as well as average accounting rate of return methods. Right? The most important criteria that we uses are NPV and IRR. Once again, if you have questions, please drop your question in the discussion forum or email me. This is Kevin Zhao, your professor in finance at MTSU. It's my pleasure to work with you in this class, and I will see you in next lecture.